Welcome you all to the other session. In the previous sessions we were seeing off adder, full adder, parallel adder, BCD adder or decimal adder. Similarly, now in this session we are going to see a carry look ahead adder. The thing is, why we are coming to carry look ahead adder means, in the previous sessions in a parallel adder or decimal adder we were waiting for the carry to come to the next stages to generate sum for the next stage sum generations. In this carry look ahead adder we are going to generate carries in the initial stage itself, means whether my next stages are depending upon my carry or not. Now previously if you observe clearly, I used to have full adders like this. For these 4 full adders, my initial bits were added. A0, B0. If a carry is generated, it should get propagated to the next stage. This will be A1, B1, C1 should go to the next full adder. A2, B2, C2 should go for the next stage. This will be A3, B3. This will give you C3 value. Here S0, S1, S2, S3. Now initial stage my carry I am considering to be S0. So to generate S1 I should wait for C0. To generate S2 I need to wait for C1. To generate S3 I need to wait for C2. So here there is a propagational delay on my carry which need to be carried for the next stages. So I am always waiting for this carry to generate my sum values. This was making a disadvantage in this particular architecture. So to avoid this condition, we are coming up with a new technique where I am looking for a carry in advance to generate my sum values. Like how? What is the technique in it? Let's see. Now you know the full adder structure. This is a full adder structure where I am adding 2 bits AI and BI, which is generating, that is PI, and third bit CI is also added up to generate SI. My representation, I am giving my variables as AI, BI, PI as first sum, PI along with third variable is giving me sum, that is SI. Now this product of this AI and BI, that is I am representing with a GI. Along with that GI, my value CI is also added up to give my carry value CI plus 1. Now my PI, you know, PI is equal to AI in exclusive with BI, the same XOR operation, whatever the XOR operation, the direct formula I am writing here. Next GI, GI is AND operation between AI and BI. Next SI, SI means PI in exclusive with CI, PI in exclusive with CI. Next, my final carry next stage which need to get propagated to the next stages, my CI plus 1 is given by GI plus PI into CI. So this is my 4 formulas. This is my one full adder structure. This is one full adder structure. Now I am used based upon this particular thing. I have got my these formulas. Now let us see how these formulas will help me to avoid a carry generation and propagation, and without using my carry, how can I get on to generate my S1, S2, S3 values also. Let us see them. Now I got formula, that is CI is equal to GI plus PIC. Now first stage, for I is equal to 1. For I is equal to 1, my value will be C1 is equal to G0, P0, C. First stage, C in, that I am taking. Next, for I is equal to 2, that is C2, G1, P1, C1. Now you know C1 value. So I am substituting C1 value, that is G0, P0, Cin. I am substituting here, so I got this particular expression. Now for I is equal to 3. Now I got G2 plus PC2. Now I know C2 value, I am substituting C2 value, I got this particular. Now if you observe, the carry 1, carry 2 or carry 3 is not depending upon any of the carry generated in the next stages. But it is not depending upon either C1 or C2 or C3. It is just depending upon my initial stage carry in only. Means I should not, or I cannot wait for any kind of carry to be generated and propagated. I should just see the initial stage carry itself. So with this expression I am clear that I can generate my sum values without the help of C1, C2, C3 or C4 also for the next step. You can observe clear the expression doesn't contain any C1, C2, C3, C4. So based upon these equations, we can prove that the carry generation and propagation is not needed for generating the sum values. That is S3, S2, S1 and S0. So using those expressions, I can directly connect my A3, B3, A2, B2, A1, B1, A0, B0 and initial stage is C0 to a carry look ahead adder. And from there, I can propagate my values P3, P2, P1, P0 directly to generate my S3, S2, S1, S0. So this is how we use the technique for generation of sum values without depending upon my carry. Let's get on to the next topic, decoder. Now decoder is a technique converting one form of code to the other form of code. What is code actually? Like how the code can be converted. Now the technique is I am going to convert n inputs to 2 power n outputs. Decoding technique. Decoder means generally n inputs I am going to provide, I am going to get 2 power n outputs. For example, I have taken 2:4 decoder. Means I am having 2 inputs and I am going to generate 4 outputs. Similarly, I can also have 4 inputs. 2 power 4 is 16. Similarly, if I am having 3 inputs, 2 power 3 will be 8 outputs. So 2:4 decoder I can have 4:16 decoder, I can also have 3:8 decoder, basic thing. In a smaller way, the 2:4 you can replicate the same thing for 3:8 or 4:16. Now I am having 2 inputs A and B with one enable input. This enable means it is going to act as a switch. Means if enable is equal to 1, then my decoder is going to be in active state. If enable is equal to 0, this is going to be in off state. Now that is 2:4 decoder means I am having 2 inputs, 4 outputs, Y0, Y1, Y2, Y3. Now based upon this block diagram, we will have a truth table or functionality table of my decoder. Now if you observe my enable pin, this is my enable pin. Now for enable pin 0, now as 2 inputs I am going to have 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. Now my 4 outputs Y0, Y1, Y2, Y3. Now in this decoder I am going to keep only one output to be high at one point of time. Now what happens when I am keeping enable as high? Now 0, 0 combination I am keeping only Y0 to be high and remaining will be at low. For 0, 1 combination only Y1 will be high, remaining will be 0. For 1, 0 combination only Y2 will be high, remaining will be 0. For 1, 1 combination only Y3 will be high, remaining will be low. So based upon this particular functionality, I am going to have my logic diagram to be drawn. Now combinations 0, 0, 0, 1, 1, 0, 1, 1. Now you can see I got A, I got B. A with A bar, B with B bar. Now A bar, B bar means 0, 0 combination. This is 0, 0. This is 0, 1. This is 1, 0. The last one is 1, 1. So Y0 is giving me A bar, B bar. Y1 is A bar, B. Y2 is A, B bar. Y3 is A, B. So I got all my 4 values for a decoder. Means I am converting one form of code to the other form of code using a decoding technique. Okay. This is where we'll end up the session here. Thank you one and all.